We're going to take a look at the practice quiz for Standard 7. So this is on operations with rationals, and the first question asks for us to graph the function and identify the key features of the graph. So I have already typed it into Desmos over here on the right, and I'm going to walk through how to pick everything out by also just taking a look at the given function. So let's start by just factoring out what you're given. So x minus 1 in the numerator doesn't factor further. But in the denominator, we could break up x squared minus x minus 6 with what will multiply to give us negative 6 and what adds to give us negative 1. So we could say that would be x and negative 6 when we multiply and add to get negative 1. So the numbers that would help would be negative 3 times 2, because negative 3 plus 2 would also add up to negative 1. So we just write those into our factors, x minus 3, x plus 2. So then you notice that none of the factors you're given cancel out. So you have no holes in the graph. So I'm going to write that at the bottom. The vertical asymptote comes directly from where your denominator would equal 0. So where x minus 3 or x plus 2 equals 0. So you could set them equal to 0 and think about it, if it helps. So x minus 3 equals 0 at x equals 3, because 3 minus 3 would equal 0. X plus 2 equals 0 would be where x equals negative 2. So the other way to think about it is with those basic binomial factors, you could just change the sign. And so that's it for vertical asymptotes. The horizontal asymptote we could get by just looking at the degree of the numerator, which is 1, because that's our highest exponent, compared to the degree in the denominator, which is the 2. So the degree is bigger in the denominator, so our horizontal asymptote is automatically y equals 0. You can also look over here on my graph on Desmos and tell that it approaches 0. It doesn't go past that. That's kind of where it levels off horizontally. We could also see that our vertical asymptotes match what we wrote. X equals 3 and negative 2 are 2 vertical asymptotes. So the only other things we need are our intercepts. And I'm just going to use Desmos to quickly pick those out. So if we zoom in a little, we see that we have an x-intercept at 1, 0. And our y-intercept is at 0.167. All right, so the only other thing we need to do is actually sketch the graph. So let's use our asymptotes to help guide where we're going to sketch it. So I'm going to sketch the vertical asymptote at x equals 3 by drawing just a dashed vertical line at x equals 3. And another one at x equals negative 2. And then I'm going to draw a horizontal asymptote at the y equals 0, which is just the x-axis. And then by looking at Desmos, you just have to sketch what you see as your branches. So we have a little branch over here. We have another one right here. And then in the middle, it crosses through really close to 0. So just sketch it as best you can. And then that would be it for number 1. In number 2, it says to graph the function and identify the key features of the graph. So if you notice, there's actually nothing that we need to factor out. So we could go ahead and start picking out some of the things that are listed. I like to start with the transformations. So in the denominator, we see we have x plus 2. That means it's going to shift to the left 2, which means our vertical asymptote is directly affected by that. So it's going to be at x equals negative 2. Then I'm going to go over here and just go ahead and try to sketch it on my graph. So at x equals negative 2, I have a vertical asymptote because it shifted left 2. Then it also went down 5 because of that minus 5 out there in the back, which makes my horizontal asymptote go down 5. So it'll be at y equals negative 5. I'm going to go ahead and draw that on my graph as well. And I'm going to go ahead and type it in and take a look at my graph, and then I'll finish up what they were asking me. So let's type in negative 3 over x plus 2 minus 5. So I can see my graph is shaping up to look like what I've planned for. I have a vertical asymptote at negative 2, and I have a horizontal asymptote at negative 5. And then I can see the branches of my graph belong here and over here, and I have no holes in the graph because none of my factors canceled out. But I do have a few more transformations that I need to write down. You have an a of negative 3. So a negative a makes it reflect over the x-axis. So I'm going to write that down here at the bottom where it says transformations. Reflect over x-axis. And then the 3 makes it have a vertical stretch by a factor of 3. And those are hard to tell on the graph because it kind of looks already curved a lot, and so the stretch is just hard to see visually, but it's there because we know a is greater than 1, so it is stretched. Now we just need our intercepts. So let's look over here on Desmos and help us pick them out. So we have an x-intercept at negative 2.60 and a y-intercept at 0, negative 6.5. And then we just need, well, we've already sketched our graph, so I guess we're all done with that one. So that's it for number 2. Let's look at number 3, 4, and 5. They're all actually really similar to one another. We're going to simplify, multiply, and divide rational expressions. So the first step that we're going to do is factor everything out. So in number 3, I'm going to factor the numerator. It's a difference of 2 squares, so I'm going to put the square root of x squared would give me x, and the square root of 9 would give me 3. And then I need a positive and a negative for those factors. And then in the denominator, I need to figure out what will multiply to give me negative 3 and what will add to give me 2. So that would be 3 times negative 1, because 3 plus negative 1 equals 2. So I'm going to write x plus 3 and x minus 1 for my factors. Then you want to see what would cancel out. So factor first is definitely the right thing to do to start out. So factor first. Step 2 is to cancel common factors. So let's look at that. I have x plus 3 at the top and I have x plus 3 at the bottom. So I know that x cannot equal the number that would make x plus 3 equal to 0, which would be x equals negative 3. So I'm going to go ahead and write that down there where it says x can't equal, because negative 3 is my first restricted value that I have found. Now I'm just going to write the simplified form of my rational expression. So I have x minus 3 over x minus 1. And then you have to look at the denominator because that cannot equal 0 either. So x minus 1 equals 0 is my denominator, or x minus 1 is the denominator. But x could not equal 1 because that's where that would equal 0. So let's put right simplified form. And step 4 is to state the restrictions. Okay, my dog is at the door and needs to be let in the house. So just hang on 1 second because he's going to scratch the door down and then we'll continue. Come on in, Scout. Okay, let's look at number 4. It says multiply the following rational expression and state any restriction. So it's a very similar process to the one that we were just looking at. So let's start by factoring everything out. In my numerator on my first fraction, I got to multiply to get 4 and add to get 4. So that would just be x plus 2, x plus 2. In the denominator, I have a difference of squares. So the square root of x squared is just x. So I'll put that in each one. I need a plus and a minus. And then the square root of 49 is 7. And let me just review that you can also use Desmos to help you if you have trouble factoring. So let's just take a look at that real quick. If I type x squared plus 4x plus 4 over here, if you notice, you have a double root at -2, which means you have factors of x plus 2, but there are 2 of them, which is what we got when we factored out our numerator. So that would still work to help you out. And if you type x squared minus 49, notice your roots are at -7 and 7. So our factors are x plus 7 and x minus 7. Then we could factor out an x, and you have x minus 7 left over. So if you use Desmos, you could type in x squared minus 7x. And notice it touches at 0 and 7. So that's why I have to put the x in the front, because that's what the 0 would look like as a factor. And then x minus 7 goes with the fact that it touched at positive 7 on the x-axis. Then I'm going to write down the denominator of x plus 2. Now that I have everything factored, I'm going to cancel common factors. So I have an x plus 2 at the top and x plus 2 at the bottom. Got x minus 7, top and bottom. And that is it. So go ahead and write down that where x plus 2 equals 0 is a restricted value. So I'm going to write -2 down there because that's where those factors would have equaled 0. And then where x minus 7 equals 0 would also be restricted, which is at positive 7. And then let's bring down what we have left, because we got to clean this up. We have x times x plus 2 in the numerator, and we just have x plus 7 in the denominator. So the last restriction is where that denominator would equal 0, because that's also something that's undefined. We cannot have a denominator equal to 0, so we have to say x cannot equal -7. So then we're finished. We have our simplified form, and we've stated our restrictions. Same thing here. We had simplified form in number 3, and we stated our restricted values. So I'm going to put a box around that whole thing. Okay, one more problem, but very similar to the 2 right above there. The steps are very similar to number 3. That's why I didn't rewrite them. We're going to factor first. We do have to keep it, change it, flip it this time because we're dividing and we want to turn it into multiplying. Then we're going to cancel common factors. We're going to write it in simplified form, and we're going to state our restrictions. So let's take a look. Number 5, x squared minus 4. I'm going to just try to move Desmos out of the way so you have a full screen view of this one. All right, so x squared minus 4 is a difference of squares, so we would factor it into x plus 2, x minus 2, because those are the square roots of those terms you're given. We have y squared minus 12y plus 36. So you want to think of what will multiply to give you 36 and add to give you -12. So that would be -6 times -6. Because -6 plus -6 would also give me -12. So let's write those down. Then I'm going to go ahead and keep this first fraction in the same order it was given. I just factored it out. I'm going to change the sign to multiplying. And then as I factor out the second fraction, I'm going to flip it or write it as its reciprocal. So if I take out a 5 for this numerator, I'm going to put it in the denominator when I rewrite it down here. So it'll be 5, and then y minus 2 is left over. And the last part of factoring, I got to figure out what will multiply to give me -6 and add to -5. So that would be -6 plus 1. So then we see what would cancel. So let's write some steps again just to review. First, factor, and let's say keep, change, flip. We can do them all in one step to save us a little bit of work. Step 2 is very similar to before. We're going to cancel common factors. So let's look for common factors now. We have x minus 6 at the bottom and the top, so those go away. Notice there's another, y minus 6. I think I said x. Even though there's another y minus 6, you cannot cancel that one because it's only 1 for 1. Like a pair of them would cancel out. You got y minus 2 cancels out. So let's go ahead and write y cannot equal what would make those equal to 0. So if you think about it, set them equal to 0. Y cannot equal 6 or 2. And then let's write what we have left. So we have y plus 2, y plus 1 at the top. At the bottom, we have 5 times y minus 6. So that's our simplified form, which would be our next step to do, is to write in simplest form. And along the way, we've already been stating some restrictions, but we need to make sure we've covered everything. So let's put state restrictions on the variable, which is one more thing we need to look at is our denominator. So where this denominator would equal 0 would be where y equals 6. So y cannot equal 6, but I've already listed that as a restriction. So I don't need to relist it since it's already there. You only need to write it once. If you do happen to write it twice, it's okay. You just don't need to. All right, so that is it for practice quiz for standard 7.